Very good afternoon, children. So in the last video we have seen about the mole concept. So calculation of the number of moles, number of atoms, number of molecules, and what is the volume occupied and everything. Now the second part of that, under the same topic, that is percentage composition, empirical and molecular formula calculations. So percentage composition. So what is the percentage composition? We will see first. Suppose let us consider water is given to you. What is the percentage composition of hydrogen and what is the percentage composition of oxygen in 18 grams? In 18 grams of this, what is the percentage compositions they will be asking. So now how to calculate the percentage composition you will see. First you have to calculate molecular weight of H2. Molecular weight of H2. It is equal to how you will be calculating how many atoms of hydrogen are given? 2. Into atomic weight of hydrogen is 1 plus 1 into 16. So it is 2 plus 16, it is total 18. So molecular weight of water is how much? Molecular weight of H2 is 18. Now I need to calculate mass percentage of hydrogen. Okay, mass percentage of hydrogen equal to what will be the general percentage formula? Suppose in a class of boys and girls, what is the percentage of girls? Means what you will write? Number of girls by total number of students into 100. In the same way here also, mass percentage of hydrogen is nothing but mass of hydrogen in the compound by mass of compound into 100. Okay. He has given in 18 grams. Let us consider in 18 grams. Mass of compound is 18. So now mass percentage of hydrogen equal to mass of hydrogen. How many hydrogen atoms are there? 2. So 2 into atomic weight of hydrogen 1 by mass of the compound is 80 into 100. 2 ones are 2 nines. It is 100 by 9. How much it is coming? 9 divided by 100. 9 ones are 9, 10. 9 ones are 9. Again 10.0. 9 nines are 81. So it is 1.0. Again 1. Okay. So 9. It is coming around some 11.1 percentage. Now mass percentage of oxygen. How much it will be mass percentage of oxygen? Directly you can apply two things. Only two compounds are there. So 100 minus that. 100 minus 11.1, it will be coming around 89.9%. Directly I guess. Otherwise, what is the step? Any mass of hydrogen in the compound 16 by 18 into 100 we have to make it. Then you will be getting the answer. Okay. So that is about the percentage composition. So percentage composition, what is the generalized formula now? What I can write? So mass percentage of an element equal to what I can write? Mass of that element, mass of that element by mass of compound into 100. This is the general calculation part. Mass percentage of the element is equal to mass of that element by mass of the compound into the mass percentage of that particular element. If you have any doubt, you can ask me. So, in general, now I will make a clear note of it. So, how to calculate the mass percentage? First, what you have to do, first step is what? Calculate the molar mass of the given compound. Molar mass of the given compound. How you will calculate the molar mass? That is nothing but molecular weight. What we call it? Molecular weight. Molecular weight of the compound. Second, what you will do? You have to apply the formula. What is that formula? Mass percentage of an element is equal to mass of, what we will write, mass of that element in compound by molar mass of compound of the compound into 100. So this is all about the percentage composition. Okay, how to calculate the percentage composition. Okay, for your practice. Okay, for practice, you calculate first. Calculate the percentage composition of the percentage composition of various elements present in first C2H5OH. What is this? Ethanol. It is also called as ethyl alcohol. Okay, C2H5OH. You have to calculate the various percentages. Next, second one is what is blue vitriol. Blue vitriol formula is what? CuSO4 5H2O. Okay, blue vitriol, that is CuSO4 5H2O is called as the blue vitriol. Means you have to calculate the percentage of carbon, percentage of hydrogen and percentage of oxygen in the first one, and in the second one percentage of copper, percentage of sulfur, percentage of oxygen and percentage of hydrogen. Okay, these all you have to calculate. Okay, note down and start doing the calculation. So blue vitriol is nothing but copper sulfate 5H2O, CuSO4 5H2O. So percentage composition means what? First you have to calculate how you will calculate ethyl alcohol percentage composition. First you have to calculate the molecular weight of this total, and next you should know what is the atomic weight of carbon, hydrogen and oxygen, and then write this formula and do. The next we will be learning about the empirical formula and molecular formula. Okay, empirical formula and molecular formula. So what is empirical formula and what is molecular formula we will see. So generally, what is the molecular formula of water means you will write directly H2O. Means it specifies what are the elements present and what is their exact ratio. Hydrogens are 2 and oxygens are 1. That is called as molecular formula. Whereas the empirical formula, it gives the information only regarding the elements present. What is the empirical formula for water means HO. That's all. OH. We will write it as OH. OH is the empirical formula for water. And for water, what is the molecular formula means H2O. What is the difference in empirical formula and molecular formula you see? It gives the exact ratio. Hydrogens are 2 and oxygen is only 1 atom. So that is the difference between empirical formula and molecular formula. So let us write the definition. Empirical formula. It represents the simplest whole number. The simplest whole number ratio of the various atoms present in a compound. Whereas molecular formula what is molecular formula? It represents the exact. It represents the exact number of different types of elements. Different types of elements present in a molecule of a compound. Present in a molecule of a compound. Suppose, let us take example. Okay, molecular formula of glucose. Molecular formula of glucose. How you will write it? C6H12O6. We all know this. C6H12O6 means you are saying the exact number. But what is the empirical formula? Empirical formula of glucose. Whether CHO? No. It is CH2O. What is the difference? Why is CH2O you have written? That we will learn now. So molecular formula and empirical formula definition you see. The simplest whole number ratio of the various atoms present in a compound. It is the simplest, not the exact. Here, it is not the exact. Means what? The simplest. Okay. So here also it will be that only. Means the simplest ratio. How we are going to get the simplest ratio, that we will see now. Okay, empirical formula is nothing but the simplest whole number ratio. How you are going to get the ratio, that is important. Okay, here you see oxygen and OH2 you are writing. How it is, that you will get it now. So not only it represents the simplest whole number ratio, and here molecular formula. In the starting what I said, empirical formula represents only the atoms present, but in the simplest ratio, this is the way. You note that we will have a discussion regarding what is the relation between this empirical formula and molecular formula, and how we will calculate the simplest ratio also. Okay, so what is the empirical formula of water? OH. What is the formula of water? Molecular formula H2. Now we will be discussing about the relation between empirical formula, empirical and molecular formula. Okay, molecular formula. What is the relation between the empirical and molecular formula? Simple. Molecular formula equal to empirical formula taken n times. Then what is n? N equal to molar mass by empirical formula of mass. Molar mass by empirical formula of mass. Sir, what is molar mass? Molar mass is nothing but molecular weight. Molecular weight of a particular compound. Okay, so you can write like this also. Molecular weight by empirical formula of H. Empirical formula mass. So this will give you the relation. Okay, molecular formula is written like this: empirical formula taken n. How you will calculate n? Molecular weight of the compound by empirical formula mass of the compound. Okay, we will have one problem and then you will get clarity regarding this. Hope you have put it. Right. Now, one problem we will see. Okay, how to calculate it. Okay, how you will be writing the empirical formula and molecular formula of a compound. Okay, so first thing is a compound contains 4.07% hydrogen, 24.27% carbon, 71.65% chlorine, 71.65% chlorine. Okay, its molar mass is 98.96 grams. What are the empirical formula Okay, so what is given? A compound contains 4.07% of hydrogen, 24.27% of carbon, and 71.65% of chlorine. First of all, you have to check whether it is 100% or not. Seven 190, 62819, 44819. It is 99.99% only. It is not exactly given percentage. Okay, it is only 99.99% only it is given. Then how you will get exactly? So I think there we may be done mistake. It may be 6.6. Make a correction, and it will be 10% now. Okay. Now how you will be doing? This means first of all you have to identify what are the elements given. What are the elements given? First you identify the elements. Next write their percentages. So first what are the elements given? Hydrogen, carbon, chlorine. These are the elements given. And write their percentages. 4.07. 24.27 and 71.66. These are the percentages given. Next you write, you calculate the atomic ratio. Atomic ratio. How you will get the atomic ratio? That is also important. How you will get the atomic ratio? Atomic ratio, how you will get it? So percentage of element by atomic mass of element. The atomic mass of the element. So atomic ratio is nothing but percentage of the element by atomic mass of the element. Then you will get the percentage. Okay. How? 4.075. What is the atomic mass of hydrogen? 1. So it is 4.07. Next, 24.27 by carbon atomic weight is how much? 12. Very good. So it is 12 to the 24 point. Again 24 it is there. Means 0. 12 to the 24. Okay, again 3. 30 means how much? 30. 30 means 12. 2 is again. So let it be. Up to 2 places we will be. Next, chlorine. 71.66 by how much? What is the atomic weight of chlorine? 35.5. Now it is coming around how much? 35.5 plus 2. So 35 2s are 70. 71 means 2 point. Still 16 it is coming. It won't go. So 0. 166. 166 means 35.5. 3s are, it won't go. Again 2s are. So atomic ratio is this. So this is the atomic ratio what you have got. Now we will calculate the least ratios. How you will get the least ratio? Least ratio, how you will get it? How you will get least ratio? Least ratios, how you will get means atomic ratio by least atomic ratio. Okay, the least atomic ratio you have to calculate. So the least atomic ratio, how you will get 4.07. What is the least? 2.0. Here 2.02 by 2.0. Here 2.02 by 2.0. Approximately you write. So it is 1. It is what? 2.0. 202 divided by 407, 4 means approximately it is coming around 2. So that is the 1. Some 2 point it will be. Okay. So simple ratio or simple whole number ratio. You make it as simple whole number ratio. So it is some 2 point means 2. It is 1. It is 1. Now you got the simple whole number ratios. The next step is what? Empirical formula. Okay, you see here. Empirical formula is the simple ratio H to C1 CL1. That is nothing but you make it somewhat clear. H to CCL. You can write like this also. C H to Cl. This is the empirical formula of the given compound. What is that? Empirical formula of given compound is what you have got. CH to Cl. You have got the empirical formula of the compound as CH to Cl. Okay. Now, how to calculate molecular formula? How to calculate the molecular formula, that we will see. In the meantime, now you see, I am just playing this. We all know that molecular formula is given by what? Molecular formula equal to empirical formula taken N. But I don't know N now. So N equal to what? Molecular weight or molar mass of compound by empirical formula mass. Empirical formula mass. So N equal to molar mass of the compound is given for us. How much it is? 98.96. By molecular formula is how mass, how much? Here I am using CH to Cl. Means carbons are how many? 1. So 1 into 12, 12. Hydrogens how many? 2. So 2 into 1, 2. Chlorine how many? 1 into 35.5. It is 35.5. So total how much? 0.5? 9, 49.5. So it is coming 49.5. Okay. So 49.5. 2s are how much? 2 5s are 10, 2 4s are 18, 19, 99. Means it is approximately equal to 2. So now the molecular formula will be how, like the molecular formula is how it will be. So I can write here now molecular formula of the compound. Molecular formula equal to empirical formula. What is the empirical formula? CH to Cl. Take N. N means what? 2. So I can write it as C2H4Cl. Okay. So the molecular formula of the given compound is what? Molecular formula of the compound equal to C2H4Cl. So this is the molecular formula. Molecular formula is how much? C2H4Cl. And the empirical formula is CH2Cl. I think now you have got a clarity how to write the empirical formula and molecular formula of a given compound. First, what you have to do, you have you are writing the empirical formula. How you are writing the empirical formula? First, hydrogen how many? 2. So H2. Carbon how many? 1. C1. Chlorine how many? 1. Cl1. So I can write it as H2CCl. I am making it very clear. Carbon, hydrogen, chlorine. CH2Cl. This is the empirical formula. Now I have to write the molecular formula. Molecular formula equal to what? Empirical formula taken n times. So n, how are we calculate molar mass of the compound by empirical formula mass? Already molar mass is given in the problem itself, 98.96. And empirical formula, from this I have calculated the atomic weight, molecular weight of CH2Cl and made it as to nearest whole number. I got n equal to 2. Where I have substituted molecular formula equal to empirical formula CH2Cl taken n is 2. So from C2H4Cl. This is the molecular formula of the given compound. The molecular formula of the given compound is what? C2H4Cl. So in this class you have learned percentage of calculations and also empirical formula and molecular formula calculation. So in this problem you have clearly understood how to write the empirical formula and how to write the molecular formula. And with this we are going to stop the class. If you have any doubts you can ask me.